Polonium-210 has a half-life of 138 days. In a 0.89 microgram sample of polonium-210, there are 2.54 times 10 to the 15 atoms of polonium. Show that the decay constant for polonium is about 6 times 10 to the minus 8, and hence calculate the activity of the sample of this size. There are two parts to this question. The first one is finding the decay constant, which is lambda. But if we look at what we are given, we know the number of atoms present, and that is given the symbol n, and the half-life, which is t1/2. Looking back to lambda, we need to find an expression which relates lambda to either one of those quantities which we are given. And the equation for the decay constant is ln 2 over t1/2. We can put down the value for the half-life. That's 138 days, but we need to convert that into seconds. So we times by 24 hours and times by 60 minutes and 60 seconds. This will give us the decay constant, which is 5.81 times 10 to the minus 8 per second, and the units will be, there are no units for the ln, and these are in seconds, so the decay constant has a unit of seconds to the minus 1. Once we know lambda, we can go to finding the activity, because activity, the equation for activity involves lambda and the other quantity that we haven't made use of, that should be involved there. Writing the equation, it's minus lambda n. So this equation tells that the activity is proportional to the number of atoms present. If you have more atoms there, the activity, which is how many decays there are in 1 second, will be higher. And the constant of proportionality is lambda. The minus sign shows that the number is decreasing. So as atoms decay, the number present will be decreasing, which is represented by the minus sign. But once we decide that this is the equation which will be useful, we can just put the numbers that we have in, and that will be the lambda that we just found, which is 5.81 times 10 to the minus 8 times the number present, 2.54 times 10 to the 15, and that will give us minus 1.5 times 10 to the 8 becquerels.